Let's practice solving a logarithmic equation together where we have different bases for each of these logarithms. So for this equation, we have log base 3 of x is equal to log base 9 of 6x. Right away, we want to notice that these bases of 3 and 9 are different, which makes this problem a little bit trickier than normal. When dealing with logarithmic equations with different bases, it's good to know the change of base formula. This formula states that when you have log base a of b, that we can go ahead and rewrite this as log base c of b over log base c of a. What's nice about this formula is you can go ahead and choose different values of c that make your problem a little bit easier for you as long as you don't choose 1. So let's look at the right side of this equation and see if we can go ahead and apply this change of base formula. So we have this log base 9 of 6x, and let's go ahead and rewrite this instead and say that we're going to say this is going to be log base c of 6x over this log base c of 9. Keep in mind that we can choose our value of c as long as it's not equal to 1. So let's go ahead and choose a number that makes sense in this problem where we have log base 3 on the other side of the equation. So I'm going to go ahead and write log base 3 of the 6x on top. Let's go ahead and divide this by log base 3 of 9 on the bottom. Now that both of these log expressions have base 3 in them, let's go ahead and take this expression and substitute it back. Notice now for our equation, all the logarithms have the same base of 3, so this should be a little bit easier for us. Next, we want to notice that this log base 3 of 9 is actually quite nice here. We can also go ahead and write this as log base 3 of 3 squared if you would like. And you can go ahead and use that power rule and bring that 2 in front and say this is going to be 2 times this log base 3 of 3 if you would like to. And keep in mind that log base 3 of 3 is just equal to 1. So this is really just 2 times 1, or this is equal to 2. And if you just knew that log base 3 of 9 was equal to 2 anyway, that would have been fine as well. Let's go ahead and take this value of 2 and substitute that back in. Alright, so our equation is a little bit simpler than it used to be. Now let's just go ahead and multiply both sides by 2 so we don't have to deal with any fractions here. If we do that, these 2's are going to go ahead and cross cancel on the right side of the equation. And we can write this equation of 2 times log base 3 of x is equal to log base 3 of 6x. Then on the left side of the equation, and let's go ahead and apply the power rule here. So we have this 2 times log base 3 of x, but remember that when we go ahead and condense here, we can actually take that 2 in front and rewrite this and write log base 3 of x raised to the second power. Let's go ahead and substitute that back in. And we can write that log base 3 of x squared is equal to log base 3 of 6x. Alright, so next, the only way that this equation could be true is if this x squared is equivalent to the 6x. Since these log base 3's over here match each other, we can go ahead and just drop those. And we can just go ahead and write our more simplified equation here of x squared is equal to 6x. Subtracting 6x from both sides, we can write that x squared minus 6x is equal to 0. And then we can go ahead and just solve by factoring and factor out the GCF of x here and say x multiplied by the quantity of x minus 6 is equal to 0. Using our zero product property, we know that in order for this to be true, either this x has to be equal to 0 or this x minus 6 has to be equal to 0. So for the first part, for x to be equal to 0, that would just mean x equals 0 would be a possible solution here. And for x minus 6 to become 0, that binomial, x would have to equal positive 6. Now, while you think you might be done, just be careful and make sure you check for extraneous solutions as well. Keep in mind that you can't take logarithms of these 0 values. It's got to be a positive value. So we're actually going to say that x equals 0 would be an extraneous solution. And so that being said, only x equals 6 would be a valid solution. If you go ahead and substitute it back into the original equation, everything checks out okay. So that would be our solution. Hope this helps.